So today I'm going to do a problem where we estimate a limit numerically. Many calculus classes start out with these kinds of examples to help build your intuition for what a limit is. So what this question is asking us is what is the limit of 2 minus 2x squared divided by x minus 1 when x approaches 1? So basically what this question is asking is, as our x values for this function get closer and closer to 1 from both sides, so from numbers bigger than 1 and from numbers smaller than 1, as those x values approach 1, what do our y values approach? And first, let's think about this sort of graphically. So let me pull up a graph of this. And what we can see here is that our graph is actually a line, kind of a cleverly disguised line. But there's one exception. So we want to notice that we have this x minus 1 in the denominator. So we plugged in just 1 into this equation. We notice our denominator equals 0. So even though our graph looks like a line, there's essentially a point missing on our line. So let's just look and see, and that's okay for limits. Like at limits, we don't care what happens at 1. We care what happens on the graph when we're approaching 1. So what we're asking here is, as our x values get closer and closer to this 1 value from this side and from this side, what's happening to our y values? Well, we can see that our y values, as we go from like 0 to 1, are getting closer and closer to this -4. Now notice if we hovered over this point here, it's actually undefined at this point, which is what we were talking about before. Since this x minus 1 is our denominator, there is no point at 1. There is no point on this line because 1 is undefined for this function. We do notice that even though it's not defined here, it seems to be approaching, our y value seems to be approaching -4, and the same is true for our other direction. As we get closer and closer to this, to x equals 1, our y value seems to be closer to this -4. So it seems like we're getting close to -4. But let's go ahead and estimate numerically to see if we arrive at the same conclusion. So the first thing we want to do when we estimate limits numerically is we want to select some good points. So we want to get closer and closer to this 1 to see what happens. So I'm going to go ahead and start on the left side, and I'm going to start at this 0.5. Let's go ahead and set the point 0.5. And all we're going to do is we're going to plug this 0.5 into our equation for where we see x in it. So, and that's just so we can figure out the y value. So we have 2 minus 2. We'll plug in our 0.5 squared divided by, plug in our 0.5 again, minus 1. And so we'll go ahead and just do the steps here. So, and if you don't know these numbers by heart, you can always just break out a calculator. Let's just go ahead and do that. So we can see that we want to know what 0.5 squared is. That's 0.25. And we're doing that 0.25 times 2, which is 0.5. So we know we have 2 minus 0.5 here. Then we have this 0.5 minus 1, which is -0.5. And again, it's okay if you can't do these in your head. Just go ahead and break out your calculator and get them out if for some reason you had a problem with this arithmetic. And so we have 2 minus 0.5 is 1.5 divided by -0.5. And this is equal to -3. And so what we're going to do is we're just going to take this -3 and we're going to put it right here. And then we're just going to repeat the process, but we just want to pick numbers that are closer and closer to 1. So this time I'm going to pick I'm going to pick 0.9. And then just repeat the process. So we have 2 minus 2, and plug in our 0.9. Squared divided by 0.9 minus 1. And this equals, so let's go ahead and do 0.9 squared equals 0.81 times by 2 equals 1.62. So we have 2 minus 1.62 divided by 0.9 minus 1 is 0.1. Oh, negative 0.1, sorry about that. And then let's just put this through our calculator. So we have 2 minus 1.62 minus 0.1. Sorry. 2 minus 1.62 equals, let's divide this by negative 0.1. And we get negative 0.38. Negative 3.8. Excuse me. Alright. And let's go ahead and just do one more value. And this time, let's go ahead and pick something really, really close to this 0.1. So let's go ahead and pick this point here, which is 0.99. And again, we just want to go ahead and just do the same steps we did before. We just want to plug this 0.99 in for our x in our function. We have 2 minus 2 times 0.99 squared divided by 0.99 minus 1. Go ahead and break out our calculator. We have 0.99 squared times 2, 1.9602. We have 2 minus 1.9602 divided by, this is negative this is negative 0.01. There we go. Alright. And so, yeah, let's go ahead and break out our calculator and do this. 2 minus 1.9602 equals, divided by 0.01. There we go. Negative 3.98. Let's go ahead and set it over there. And since we care about what happens, we need to see what happens when x approaches 1 from the left side, from this left side, and from the right side. So now we want to do the same thing, but we just want to pick numbers on the right side of 1. So let's go ahead and start with this 1.5. And go ahead and plug it into our limit. So same process. We have 2 minus 2 times by 1.5 squared divided by 1.5 minus 1. That equals, and if you're not comfortable with the arithmetic, just go ahead and put it into your calculator. 1.5 squared times 2, 4.5. We have 2 minus 4.5. We have 1.5 minus 1, which is just 0.5. And this equals 2 minus 4.5 divided by 0.5, negative 5. Go ahead and add this. So let's pick another point that gets closer to 1 from the right side. So this is 0.5. So let's get actually just pretty close here. And let's pick this point 1.1. we have 1.1 plus, yep, just repeat the process again. So 2 minus 2 times our 1.1, plugging it in for that x squared. And then we have 1.1 minus 1. Using our calculator, 1.1 squared is 1.21 times 2 equals 2.42. 1.1 minus 1 is just 0.1. So here we have negative 0.42 divided by 0.1. So let's see what that is. And this will declare to you how I got from here to here. Let me just go ahead and show you. 2 minus 2.42 negative 0.42 divided by 0.1 negative 4.2. And lastly, let's pick a point that's even closer to 1 from this right side. Go ahead and take this point here, and let's say this point here is 1.01. So let's see what happens when we plug 1.01 into our function. So we have 2 minus 2 times 1.01 squared divided by 1.01 minus 1. So this equals, breaking out our calculator, we have 1.01 squared times 2 is 2.0402 minus 2.0402 divided by 1.01, this should be a decimal, not a comma. 1.01 minus 1, which is 0.01. And so, putting this all together, we get 2 minus 2.0402. And then we're going to divide this by 0.01. And we get negative 4.02. Alright, so let's go ahead and examine our values. This is our last step when we estimate limits. We just want to look and see what value is our numbers approaching. And so we can see when we look at these values here, the values from the left hand side, when we went from 1/2 to 0.9 to 0.99, we went from negative 3 to negative 3.8 to negative 3.98. It looks like we're getting closer and closer to 4. What we can notice is we're approaching 4, and it doesn't seem like we're going past 4. It looks like as we get closer and closer to 4, our growth slows down. So it kind of looks like we're approaching 4 here. So 4 in the question mark. Let's go ahead and see what's happening from the other side. On the other side, we see the same thing. As we get closer and closer to 1, let's look back at our number line real quick. As we get closer and closer to this 1, starting at this 1.5, at 1.5 our y was negative 5, and at 1.1 our y was negative 4.2, and then when we were really, really close to our 1, we got negative 4.02. So from this side, it also looks like we're approaching 4. As we got closer and closer to 1, we got closer to this 4. And notice in neither case did we never got the number 4. We just got closer and closer to it without actually hitting it. And so when we're estimating limits, this is what we're looking at. And this may seem like a little difficult, it may seem a little guessy, and there's definitely, and that's true. Like we just looked at it this side, it could have been that it actually did go past 4, and it might have, maybe we were going to 4.1 or something. And that's kind of generally the problem with using this sort of method, is it's not reliable. So if you're just starting out in calculus and you're just starting off seeing these problems, what you should know is that eventually you will like move on from this method. But the reason we do this method and the reason it's important for you to go through the steps is it really does help you build your intuition for how limits work. It's as we approach a number on the x-axis, like this one here, as we get closer and closer to this point on the x-axis, what's happening with our y values? And let's go ahead and look at our graph one more time to kind of bring it all together. So remember before we thought that maybe the limit was 4, and it did end up being 4. As we got closer and closer to 1 on our x-axis, we got closer and closer to 4. Our y values got closer and closer to this 4. And notice that remember, it didn't matter that at 4, there is no y value 4, and that's okay for limits. At limits, we don't care what happens at x equals 1. What happens is what happens near x equals 1. And as x gets closer and closer to 1, the y values for those x's get closer and closer to this negative 4. And essentially, yeah, this is the end of this problem. So we could say at the very end that we know the answer to this problem, and it's 4. And so that's what, oh, I'm sorry, not 4, negative 4. Sorry, I guess I should use or negative 2. That's my fault. So yeah, so this is generally the process for how you estimate a limit numerically. If you have any questions, put them below, and I hope to see you in my next